Structural isomers should be a straightforward question. Now, structural ice, remember, is where you have the same molecular formula, which is just the number of atoms, that in this case 4 carbons. There's 9 hydrogens. There's another hydrogen here, and there's an oxygen here. Now, in this case, this is really wanting you to do a structural isomers that relate to alcohols. And this we've got to take care. Sometimes a question will specify that it should include alcohols, or they've all got to be alkenes or something like that, because otherwise, of course, it could actually have a different functional group. You don't necessarily have to have exactly the same functional group for this to be a structural isomer. It's just a different structure and a different structural arrangement. So obviously the first thing to do here with 4 carbons is just to draw 4 carbons in a row if we're trying to find out how many we can draw. And then just place all the bonds around, remembering they all count to add up to 4. And we'll just put an OH on the end. Now that OH could go here or here. It doesn't really matter. That would still put it in the number 1 position. And then we just fill in the OH. The H is on the rest. And that should match the formula as above. Now, of course, this would be butane 1-ol. Now, if that OH gets shifted and is placed on the number 1 over here, that would still be butane 1-ol, so that would not be a different isomer. Okay, the natural thing is to move the OH group around, so for instance to put it here. Now, I've put it in this position, and this becomes butane 2-ol. So that's the second isomer. Now, if I was to shift this over and it was to go here, well, that would still be butane 2-ol, just numbering from the left to the right. It's really as if you just flipped the molecule around. It's still the same molecule. Okay, so it would look initially that we can only do 2 isomers. However, the next trick with isomers is to recall that as soon as you get effectively more than 3, that you can start doing branches. So if we have 1, 2, 3, we can put one branching off here, and then we can just put a OH here, and this would be a third isomer. How would we name this one? Well, we name the longest chain first, which will go 1, 2, 3. So that's propane 1-ol. And we've got a methyl group on the number 2, so 2-methyl propane 1-ol. Now notice if I was to shift this OH to being on this carbon here, or on this carbon here, it would we'd still number it to be propane 1-ol, and there would still be a methyl group coming off the number 2. So just take care, and one of the good checks is if you try renaming a structure you've drawn and you end up with the same name as one you've already got, you've really just drawn the same structure again, and it may just look different to you, but it must be the same structure if it's exactly the same name for a structural isomer. Now I'm going to put an OH on the second carbon, and that gives me my final isomer, and of course that means that this will be propane 2-ol, and that the methyl group is also in the number 2, so notice it's got a different name. So the whole point in structural isomers is that they will have a different name because they do have a different structural arrangement. Okay, so remember, first thing, just start drawing them out. Don't just stare at them for a while, just draw it out. Move around the functional group if you can to different numbered positions. If you can do branches, do branches, and generally you can when you get up to 4 carbons, especially 5. And that should give you the ability to do a range of them. You can occasionally do cyclical ones like this going around. Sometimes with questions tell you not to do that, but sometimes it's okay. So there can be a range of structures that you can draw. Okay, and that's structural isomers, an example of one. Now this final bit is just to point out a common mistake students sometimes make with structural isomers, and it's just got really to do with just not drawing things correctly. what is wrong with this structural isomer that a student may have drawn? Well, they've made it appear as if the methyl group here is a side group coming off, and the student would probably think this would be named propantuol with a methyl group of the number either 3 or the number 1 carbon, but that would be incorrect. Remember, we have to number the longest chain. The longest chain here is 1, 2, 3. And this methyl group isn't a side group, it's just part of the longest chain. You can just redraw that like this. In other words, you're just bending up the bottom methyl group. So this methyl group just gets shifted to there, and of course this H would rotate down, but this is exactly the same structure. This is butantuol. So don't make that error with, you can never have a methyl group on the first carbon. So no, okay? So that's an example of structural isomers.